Okay, welcome back to another triangles video under the similarity and congruence umbrella. This one's on something called metric relations. Let's take a look. Okay, when we talk about metric relations, we're talking about a set of formulas that work when we see one very specific type of triangle in a question. Now what we're looking for so that we can put metric relations to use is a right triangle that has a line drawn through it going from the right angle to the hypotenuse. And remember, the hypotenuse is that longest side of a right triangle, always across from the 90-degree angle. Now stop right there. Stop right there. There's something really important you need to know about that line drawn through the right triangle. It has to meet the hypotenuse at a right angle. So when you draw it through the triangle, or when it's drawn through the triangle for you, you have to make sure that it's identified as meeting the hypotenuse at a right angle, kind of like with the square that's on the screen here. And the other thing to know about that line drawn through the triangle is that it has a name, and it's called the altitude of the right triangle. Now what happens when there's a line drawn through the right triangle is we've actually split that bigger triangle into two smaller right angle triangles, and all three of them are similar to each other, the two small ones on the inside and the big triangle on the outside. Now we're going to get to that concept of similarity in future videos, but for now all we need to know is how to use the formulas called metric relations. Now I know there's a whole bunch of them and that can be really overwhelming, but we don't use all these metric relations formulas at once. In fact, just think of them as kind of like a toolbox. A toolbox where when you have a question to answer, you're going to need to go and use one or two or three of those tools, but never all of them for the same question. Now, if you can do Pythagoras, then you can definitely do metric relations. The most important thing here, though, is that we label this triangle properly. Now, there's a lot of different parts at play here, so we have to make sure we're careful when labeling the triangle. Now the easy ones to label here are sides A, B, C, and H. I'm going to start with sides A and B. Just like in Pythagoras, sides A and B can be placed on either of the shorter legs of that large right triangle. And they're interchangeable, so go ahead and put them on either of the shorter legs that you like. And side C, just like in Pythagoras, goes on the hypotenuse of that big triangle. It represents that entire large side of the big right triangle. Now H is pretty easy to label also. It goes on the altitude, that line that's drawn through the big triangle. Now the only ones left to place are sides D and E. Now D and E are the two small portions of that large hypotenuse. And we've got to be really careful here placing these in the right spots. So D goes on the side of the hypotenuse that is closest to the A that you labeled. So depending on where you labeled A before, you have to call the portion of the hypotenuse that's closest to A, you have to call that D. And the last one to label is E, and you guessed it, it goes on the portion of the hypotenuse that's closest to side B in the large triangle. So B and E go together, and A and D go together on the other side. Now on any given question in metric relations, it's entirely possible that you've labeled your triangle differently from someone else doing the same question. This will all depend on where you decide to put sides A and B. But don't worry, your answers will be exactly the same in the end as long as you follow the instructions properly and don't make any math mistakes. So let's get right to a question. And you can see that in the example on the screen, I've written out all my formulas on one side, and I've written out a list of all the labeled sides on the other. Now you can see that I have known values. I was given values for sides A and C. So in that list over on the left, I'm going to fill in the numbers beside A and C. Then I'm going to go to my formulas and underline all the letters A and C that I have in each of those formulas. Now doing this underlining in the formulas is going to help me choose which formula I can work with. It's not always obvious, and it might not always be the formula that I really want in the end. But anything that you can figure out in these metric relations questions is a piece of the puzzle. And sometimes you have to figure out sides that you don't think you need just so that you can move on to the next step and get closer to your answer. So here I'm going to choose the a squared equals c times d formula so that I can find the length of side D. Now pretty simple here, all I'm going to do is fill in my values, square that a value, and then divide by c to isolate the d value. Now as soon as I do that, I'm going to go to my list on the left and fill in the number that I just found for d. And once I do that, it's back to the formulas, and I underline everywhere I see the letter D because I also know that value. And now finally, I can use a formula, now that I know those two values, to find out the final answer that I'm looking for, and that's the value for H. Now there are other routes to get this answer. This is just the way that I've chosen. But if you decide to go another way, sometimes it might be longer, or you might even find it easier. There are other ways to get to the answer. This is just the way that I'm choosing here. All I have to do is take the square root of that number to isolate the H. Notice it had the squared on it, so I got to take the square root to figure out what H is. And it's as easy as that. That one was a couple of steps. Sometimes you'll be able to get your answer in just one step, and sometimes it might even be more than two. But if you use the formulas properly, you'll always get to your answer through metric relations in this type of triangle. Now remember, in these types of questions, it's really important that you label all your sides properly. A, B, and C are pretty easy. We've done those for Pythagoras. H is pretty easy. It's that line through the middle. But D and E go in very specific spots, and remember where. D and A get paired together, and E and B get paired together on their respective sides of that large triangle. Now remember, it's worth your time to write down all these 8 formulas every time you start this. You never know which one you're going to need to use. And don't forget also to write down that list of known values. This is going to help you choose what formula you need to use to arrive at the answer you're looking for. It looks like we're off to the races with metric relations. Let's watch a couple of examples on how it works.